Chapter 12 Organic Chemistry. Some basic principles and techniques. Organic compounds are the hydrocarbons and the derivatives, and organic chemistry is the branch of chemistry that deals with the study of these compounds. Tetravalency of carbon. The atomic number of carbon is 6 and its electronic configuration is 2, 4, i.e. it has 4 valence electrons. Thus carbon is always tetracovalent, i.e. it forms 4 covalent bonds with other atoms. C. Due to tetravalency of carbon it has a tetrahedron shape. Catenation. The self-linking property of carbon is known as catenation. This is the main reason of existence of such large number of compounds. Classification of organic compounds. Organic compounds: acyclic, cyclic, homocyclic, heterocyclic, alicyclic, aromatic, benzenoid, non-benzenoid. Functional groups. A functional group may be defined as an atom or a group of atoms present in a molecule which largely determines the chemical properties. Class of organic. Name of functional structure. Compounds group. Alkenes double bond equals C equals C equals alkenes triple bond, C she C. Halogens halogen, X, F, Cl, bridge, I. Alcohols hydroxyl, O. Aldehydes aldehydic, formal, CHO. Carboxylic acids carboxyl CHO acid, amides amides, CONH2 primary, amines amino, NH2 material downloaded from SUPERCOP 1/16. Homologous series. Homologous series is defined as a family or group of structurally similar organic compounds, all members of which contain the same functional group, show a gradation in physical and similarity in chemical properties, and any two adjacent members of which differ by CH2 group. The individual members of this group are called homologs, and the phenomenon is called homology. Nomenclature of organic compounds. Organic chemistry deals with millions of compounds. In order to clearly identify them, a systematic method of naming known as IUPAC system of nomenclature is adopted. The names are such that the listener can deduce the structure from it. The IUPAC name consists of 3 parts: prefix, word, root, suffix X, 3-methyoctane. Nomenclature of alkanes. Straight chain alkanes. The names of such compounds is based on their chain structure, and end with suffix, ane, and carry a prefix indicating the number of carbon atoms present in the chain. Branched chain hydrocarbons. 1. The longest carbon chain in the molecule is identified. 2. The numbering is done in such a way that the branched carbon atoms get the lowest possible value. 3. The names of the alkyl groups attached as a branch are then prefixed to the name of the parent alkane, and its position is indicated by numbers. 4. The lower number is given to the first in alphabetical order. 5. The carbon atom of the branch that attaches to the root alkane is numbered 1. Organic compounds having functional groups. The longest chain of carbon atoms containing the functional groups is numbered in such a way that the functional group attached to the carbon atom gets the lowest possible number in the chain. When there are more functional groups, then a priority order is followed as COOH, SO3H, COOR, COCl, CONH2, CN, HC equals O, equals C equals O, O, NH2, equals C equals C equals C she C. Isomerism. 2 or more compounds having the same molecular formula but different physical and chemical properties are called isomers, and this phenomenon is called isomerism. Material downloaded from SUPERCOP 2/16. Chain isomerism. When 2 or more compounds having same molecular formula but different carbon skeletons are referred to as chain isomers. Position isomerism. Compounds which have the same structure of carbon chain but differ in position of double or triple bonds or functional group are called position isomers, and this phenomenon is called position isomerism. E.g. CH3CH2CH equals CH2CH3CH equals CH3 functional isomerism. Compounds which have the same molecular formula but different functional group are called functional isomers, and this phenomenon is called functional isomerism. E.g. CH3CH2OCH3O, CH3 metamerism. It is due to the presence of different alkyl groups on either side of functional group in the molecule. X. C4H10O represents C2H5OC2H5 and CH3OC3H7. Fission of covalent bond heterolytic cleavage. In this cleavage the bond breaks in such a way that the shared pair of electron remains with one of the fragments. H3C. Bridge plus CH3 plus bridge homolytic cleavage. In this cleavage the shared pair of electron goes with each of the bonded atom. R. XR. Plus X. Alkyl-free radical nucleophiles. A reagent that brings an electron pair is called nucleophile, i.e. nucleus-seeking EGO, CN electrophiles. A reagent that takes away electron pair is called electrophile, i.e. electron-seeking EG greater than C equals O, R3C, X inductive effect, the displacement of the electron along the chain of the carbon atoms due to presence of an atom or group at the end of the chain. Material downloaded from SUPERCOP 3/16. Plus CH3CH2CH2Cl resonance effect. The polarity produced in the molecule by the interaction of two pi bonds or between a pi bond and lone pair of electron present on an adjacent atom. There are two types of resonance effect. 1. Positive resonance effect. In this effect the transfer of electrons is away from an atom or substituent group attached to the conjugated system. The atoms or groups which shows plus R effect are halogens, O, OR, NH22, negative resonance effect. In this effect the transfer of electrons is towards the atom or substituent group attached to the conjugated system. The atoms or groups which shows R effect are COOH, CHO, CN methods of purification of organic compounds, sublimation. This method is used to separate the sublimable compounds from non-sublimable compounds. Crystallization. This method is based on the difference in the solubilities of compound and impurities in a suitable solvent. The impure compound is dissolved in solvent heated at higher temp. On cooling the hot and conc solution pure compounds crystallizes out. Distillation. This method is used to separate volatile liquids from non-volatile liquids and liquids having sufficient difference in their boiling points. Fractional distillation. If the boiling points of two liquids is not much, they are separated by this method. Distillation under reduced pressure. This method is used to purify liquids having high boiling points and decomposes at or below their boiling points. Steam distillation. This method is used to separate substances which are steam volatile and are immiscible with water. Differential extraction. When an organic compound is present in an aqueous medium it is separated by shaking it with organic solvent in which it is more soluble than in water. The aqueous solution is mixed with organic solvent in a separating funnel and shaken for some time and then allowed to stand for some time. When organic solvent and water form two separate layers, the lower layer is run out by opening the tap of funnel and organic layer is separated. The process is repeated several times and pure organic compound is separated. Chromatography. This technique is used to separate mixtures into their components, purify the compounds and test the purity of compounds. It is classified as material downloaded from SUPERCOP 4/16. Quantitative analysis, carbon and hydrogen, let the mass of organic compound be mg. Mass of water and carbon dioxide produced be m1 and m2 grams respectively. Percent of carbon equals 12x m2x 144x m. Percent of hydrogen equals 2x m1x 118x m. Nitrogen Dumas method. A known mass of organic compound is heated with excessive CuO in an atmosphere of CO2, when nitrogen of the organic compound is converted into N2 gas. The volume of N2 thus obtained is converted into STP and the percentage of nitrogen determined by applying the equation. Volume of nitrogen at STP equals P1V1 x 273,760 x T1% N equals 28x volume of N2 at STP x 100, 22400 x mass of the substance taken. Kjeldahl's method. A known mass of organic compound is heated with conc. H2SO4 in presence of K2SO4 and little QSO4 or Hg in a long-necked flask called Kjeldahl's flask. When nitrogen present in the organic compound is quantitatively converted into NH4, 2SO4. NH4, 2SO4 thus obtained is boiled with excess of no solution to liberate NH3 gas, which is absorbed in a known excess of a standard acid such as H2SO4 or HCl. The volume of acid unused is found by titration against a standard alkali solution. From the volume of the acid used, the percentage of nitrogen is determined by applying the equation, %N equals 1.4x molarity of the acid x basicity of the acid x volume of the acid used mass of the substance taken halogens Carius method. A known mass of an organic compound is heated with fuming nitric acid in the presence of silver nitrate contained in a hard glass test tube known as Carius tube in a furnace. Carbon and hydrogen present in the compound are oxidized to carbon dioxide and water. The halogen present forms the corresponding silver halide. It is filtered, dried, and weighed. Material downloaded from SUPERCOP 6/16. Let the mass of the organic compound taken equals mg mass of AgX formed equals m1 gram. 1 mole of AgX contains 1 mole of X mass of halogen in m1 gram of AgX equals at mass of XX m1 gram molecular mass of AgX percent of halogen equals at mass of XX m1 gram by 100% molecular mass of AgX x m sulfur. Let the mass of the organic compound taken equals mg mass of BaSO4 formed equals m1 gram percent of sulfur equals 32x m1 by 100% 233x m phosphorus. Let the mass of the organic compound taken equals mg mass of ammonium phosphomolydate equals m1 gram percent of phosphorus equals 31x m1 by 100% 1877x m oxygen. Let the mass of the organic compound taken equals mg mass of CO2 equals m1 gram percent of oxygen equals 32x m1 by 100% 44x m1 mark. Questions Q1 suggest a method to purify a liquid which decomposes at its boiling point. A1 The process distillation under reduced pressure is used to purify a liquid which decomposes at its boiling point. Q2 How will you separate a mixture of O-nitrophenol and P-nitrophenol? Material downloaded from SUPERCOP 7/16. A2O-nitrophenol is steam volatile, therefore it can be separated by steam distillation. Q3 Larsane's test is not shown by diazonium salt. Why? A3 On heating diazonium salts loses nitrogen and could not fuse with the sodium metal, therefore diazonium salt do not show positive Larsane's test for nitrogen. Q4 Alcohols are weaker acids than water. Why? A4 The alkyl group in alcohols has +I effect due to which electron density is increases on oxygen separated by steam distillation. Q3 Larsane's test is not shown by diazonium salt. Why? A3 On heating diazonium salts loses nitrogen and could not fuse with the sodium metal, therefore diazonium salt do not show positive Larsane's test for nitrogen. Q4 Alcohols are weaker acids than water. Why? A4 The alkyl group in alcohols has +I effect due to which electron density is increases on oxygen atom, which makes the release of hydrogen ion more difficult from alcohol. R right pointing arrow O right pointing arrow HQ5 Y is nitric acid is added to sodium extract before adding silver nitrate for testing halogens. A5 Nitric acid is added to decompose NaCN and Na2S. NaCN plus HNO3 right pointing arrow nano3 plus HCN2 or CH3CH2O is expected to be more stable, and why? A6NO2 group has I effect and disperse the negative charge on oxygen atom. O2N left pointing arrow CH2 left pointing arrow CH2O. Q7 Arrange the following in increasing order of stability: CH3, 3C+, CH3CH2 CH2C plus H2, CH3CH2C plus HCH3, CH3C plus H2, CH3CH2C plus H2A7 CH3C plus H2 less than CH3CH2C plus H2 less than CH3CH2CH2C plus H2 less than CH3CH2C plus HCH3 less than CH3 3C plus Q8. Write the IUPAC name of the following CH3CH2CH3CH3CH3A82, 3-dimethylpentane Q9. Write the hybridized state of C atoms in the following CH2 equals CH, CXN-A9sp2sp2 equals CH, CXN. Material downloaded from SUPERCOP 8/16. Q10. Give the IUPAC name of the following compound. A10-2, 5-dimethyleptane. 2 marks. Questions. Q1. Draw the structures of the following compounds. A. Hex 3-enoic acid. B. 2-chloro-2-methylbutan 1-ol A1A, OCH3CH2CH equals CHCH2COB, ClCH3CH2C, CH2OCH3Q2. Explain inductive effect with example. A2. Inductive effect. The displacement of the electron along the chain of the carbon atoms due to presence of an atom or group at the end of the chain. Delta plus 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 delta plus plus delta plus CH3 right pointing arrow CH2 right pointing arrow CH2 right pointing arrow ClQ3. Explain why CH3 3C plus is more stable than CH3C plus H2. A3, CH3, 3C plus has 9 alpha hydrogens and has 9 hyperconjugation structures, while CH3C plus H2 has 3 alpha hydrogens and has 3 hyperconjugation structures. Therefore, CH3, 3C plus is more stable than CH3C plus H2Q4. Give the number of sigma and pi bonds in the following molecules: A, CH3NO2B, conj 3A4, 6 sigma and 1 pi bond. B, 8 sigma and 1 pi bond. Q5. Write the condensed and bond line formula of 2,2,4-trimethylpentane. Material downloaded from SUPERCOP 9/16. A5CH3CH3CCH2CHCH3CH3CH3Q6. How sodium fusion extract is prepared. A6. A small piece of dry sodium metal is heated with an organic compound in a fusion tube for 2 to 3 minutes, and the red-hot tube is plunged into distilled water contained in a china dish. The content of the china dish is boiled, cooled and filtered. The filtrate is known as sodium fusion extract. Q7. Explain the principle of paper chromatography. A7. Paper chromatography is based on the difference in the rates at which the components of a mixture are adsorbed. The material on which different components are adsorbed is called stationary phase, which is generally made up of alumina, silica gel or activated charcoal. The mixture to be separated is dissolved in a suitable medium and it is called moving phase. The moving phase is run on the stationary phase. The different compounds are adsorbed on stationary phase at different rates. Q8Y is an organic compound fused with sodium for testing nitrogen, halogens and sulfur. A8. On fusing with sodium metal, the elements presents in an organic compounds are converted into sodium salts, which are water soluble, which can be filtered and detected by the respective tests. Q9. It is not advisable to use sulfuric acid in place of acetic acid for acidification while testing sulfur by lead acetate test. Give reason. A9. Lead acetate on reacting with sulfuric acid will give a white PPT of lead sulfate. Interfere in the detection of sulfur. CH3COO, 2 petabits plus H2SO4 PbSO4 plus 2 CH3COOH. Q10. Under what conditions can the process of steam distillation is used? Under what conditions can the process of steam distillation is used? A10. Steam distillation is used to purify the liquids which are steam volatile and water and the liquid are not miscible with each other. 3 marks. Questions. Q1. In an estimation of sulfur by Carius method, 0.468 grams of an organic compound gave 0.668 grams of barium sulfate. Find the percentage of sulfur in the compound. A1. Mass of the compound equals 0.468 grams. Material downloaded from SUPERCOP 10/16. Mass of the barium sulfate equals 0.668 grams percent of sulfur equals 32x mass of barium sulfate x 100,233 x mass of the compound equals 32x 0.668 x 100,233 x 0.468 equals 19.60% Q2. Which bond is more polar in the following pairs of molecules? A. H3CH H3C bridge B, H3C NH2, H2COC, H3CO, H3C shush A2A, C bridge because bridge is more electronegative than HB, CO because O is more electronegative than NC, CO because O is more electronegative than SQ3. Define isomerism. Explain position isomerism and functional isomerism with examples. Two or more compounds having the same molecular formula but different physical and chemical properties are called isomers, and this phenomenon is called isomerism. Position isomerism. Compounds which have the same structure of carbon chain but differ in position of double or triple bonds or functional group are called position isomers, and this phenomenon is called position isomerism. E.g. CH3CH2CH equals CH2CH3CH equals CH3 functional isomerism. Compounds which have the same molecular formula but different functional group are called functional isomers, and this phenomenon is called functional isomerism. E.g. CH3CH2OCH3O, CH3Q4. Write the IUPAC names of the following compounds. OOACH3CH2C, CH2C, CH3BHCC, CH equals CH, CH2C close, CH2CH2CH2CH2 bridge A4 A hexane 2, 4-dione material downloaded from SUPERCOP 11/16. BHEXA1, 3-DIEN5 C1BROMO4 chlorobutane Q5. Define homologous series. Write the general formula of alkane, alkene and alkenes. A5 homologous series. It is defined as group of similar organic compounds which contains the similar functional groups, and the two adjacent members of the series is differ by ACH2 group. Alkanes CnH2n plus 2 alkenes CnH2n alkenes CnH2n 2q6. How many sigma and pi bonds are present in the following molecules? RHCCCH equals CHCH3BCH2 equals C equals CHCH3A 6A sigma bonds equals 10 pi bonds equals 3B sigma bonds equals 9 pi bonds equals 2q7. Define functional groups. Write the general formula of carboxylic acids, acid chlorides. A7 functional groups. It is an atom or group of atoms bonded together in a unique manner which is usually the site of chemical reactivity in an organic molecule. E.g. CH3OH general formula of carboxylic acids, CnH2n plus 1 COOH general formula of acid chlorides, RCOClQ8. Write a short note on differential extraction. A8 went a short note on differential extraction. A8 When an organic compound is present in an aqueous medium, it is separated by shaking it with organic solvent in which it is more soluble than in water. The aqueous solution is mixed with organic solvent in a separating funnel and shaken for some time and then allowed to stand for some time. When organic solvent and water form two separate layers, the lower layer is run out by opening the tap of funnel and organic layer is separated. The process is repeated several times and pure organic compound is separated. Q9 How carbon and hydrogen is detected in organic compounds. A9 The carbon and hydrogen present in the organic compound is detected by heating the compound with copper 2 oxide in a hard glass tube when carbon present material downloaded from SUPERCOP 12/16. In the compound is oxidized to CO2 which can be tested with lime water, and hydrogen is converted to water which can be tested with anhydrous copper sulfate which turns blue. C plus CuO2 Cu plus CO2 2H plus CuO Cu plus H2O Colorado 2 plus CaO 2 CaCO 3 plus H2O 5 H2O plus CuSO 4 CuSO 4.5 H2O Q10. Write a short note on resonance effect. Resonance effect. The polarity produced in the molecule by the interaction of two pi bonds or between a pi bond and lone pair of electron present on an adjacent atom. There are two types of resonance effect. 1. Positive resonance effect. In this effect, the transfer of electrons is away from an atom or substituent group attached to the conjugated system. The atoms or groups which shows plus R effect are halogens, O, OR, NH22. Negative resonance effect. In this effect, the transfer of electrons is towards the atom or substituent group attached to the conjugated system. The atoms or groups which shows R effect are COOH, CHO, CN5 marks questions Q1 differentiate between the principle of estimation of nitrogen in an organic compound by I, Dumas method E, Kjeldahl's method. ANS. Dumas method. A known mass of organic compound is heated with excessive QO in an atmosphere of CO2, when nitrogen of the organic compound is converted into N2 gas. The volume of N2 thus obtained is converted into STP and the percentage of nitrogen determined by applying the equation. Volume of nitrogen at STP equals P1V1x 273,760 x T1% N equals 28x volume of N2 at STP x 100, 22400x mass of the substance taken Kjeldahl's method. A known mass of organic compound is heated with conc. H2SO4 in presence of K2SO4 and little qSO4 or Hg in a long-necked flask called Kjeldahl's flask when nitrogen present in the organic compound is quantitatively converted into NH4, 2SO4. NH4, 2SO4 thus obtained is boiled with excess of material downloaded from SUPERCOP 13/16. No solution to liberate NH3 gas which is absorbed in a known excess of a standard acid such as H2SO4 or HCl. The volume of acid unused is found by titration against a standard alkali solution. From the volume of the acid used, the percentage of nitrogen is determined by applying the equation, %N equals 1.4x molarity of the acid x basicity of the acid x volume of the acid used mass of the substance taken Q2. A sample of 0.50 grams of organic compound was treated according to Kjeldahl's method. The ammonia evolved was absorbed in 50 milliliters of 0.5 mH2SO4. The residual acid required 60 milliliters of 0.5 m solution of NO for neutralization. Find the percentage composition of nitrogen in the compound. ANS. The volume OFH2SO4 used. Volume of acid taken equals 50 milliliters of 0.5 mH2SO4 equals 25 milliliters of 1 mH2SO4. Volume of alkali used for neutralization of excess acid equals 60 milliliters of 0.5 meters NO equals 30 milliliters of 1 m NO. Now 1 mole of H2SO4 neutralizes 2 moles of NO, i.e. H2SO4 plus 2 NO Na2SO4 plus 2 H2O, 30 milliliters of 1 m NO equals 15 milliliters of 1 mH2SO4 % of nitrogen. 1 mole of H2SO4 neutralizes 2 moles of NH3, 10 milliliters of 1 mH2SO4 equals 20 milliliters of 1 m New Hampshire 3, but 1000 milliliters of 1 m New Hampshire 3 contain N equals 14 grams. 20 milliliters of 1 m New Hampshire 3 will contain nitrogen equals 14 x 21,000, but this amount of nitrogen is present in 0.5 grams of organic compound. Percent of N equals 14 x 20 x 100 equals 56.01,000 by 0.5 Q3. You have a mixture of 3 liquids A, B, C. There is a large difference in the boiling point of A and the rest 2 liquids. Boiling points of liquids B and C are quite close. Liquid A boils at higher temperature than B and C, and boiling point of B is lower than C. How will you separate the components of the mixture? Material downloaded from SUPERCOP 14/16. And since the boiling point of liquid A is much higher than those of liquids B and C, therefore separate liquid A by simple distillation. Since boiling points of liquids B and C are quite close but much lower than liquid A, therefore mixture of B and C will distill together leaving behind A. On further heating A will distill over. Now place the mixture of liquids B and C in a flask fitted with fractionating column. Since the P of liquid B is lower than that of C, on fractional distillation first liquid B will distill over and then liquid C. HOTS questions Q1. Explain hyperconjugation effect. How does hyperconjugation effect explain the stability of alkenes? ANS. The relative stability of various classes of carbonium ions may be explained by the number of no-bond resonance structures that can be written for them. Such structures are obtained by shifting the bonding electrons from an adjacent CH bond to the electron-deficient carbon, so the positive charge originally on carbon is dispersed to the hydrogen. This manner of electron release by assuming no bond character in the adjacent CH bond is called hyperconjugation. Greater the hyperconjugation, greater will be the stability of alkenes. CH3CH equals CH, CH3 less than CH3C equals CH, CH3 less than CH3C equals C. CH3CH3CH3CH3Q2 in DNA and RNA. Nitrogen is present in the ring system. Can Kjeldahl method be used for the estimation of nitrogen present in these? Give reasons. Amson DNA and RNA. Nitrogen is present in heterocyclic rings. Kjeldahl method cannot be used to estimate nitrogen present in the ring because cannot be completely converted into NH4, 2SO4 during digestion. Therefore Kjeldahl method cannot be used to estimate nitrogen present in DNA and RNA. Q3 1.216 grams of an organic compound was Kjeldahlized and the ammonia evolved was absorbed in 100 milliliters 1NH2SO4. The remaining acid solution was made up to 500 milliliters by addition of water. 20 milliliters of this dilute solution required 32 milliliters of N10 caustic soda solution for complete neutralization. Calculate the percentage of nitrogen in the organic compound. ANS 20 milliliters of DIL. Unreacted H2SO4 equals 32 milliliters of N10 no sol. 500 milliliters of DIL unreacted H2SO4 equals 32 by 500 milliliters of NO equals 32 by 500 milliliters of 1NO2O, 10, extension 10 equals 80 milliliters 1NO. Material downloaded from SUPERCOP 15/16. That 80 milliliters 1NO equals 80 milliliters 1NO, so acid left unused equals 80 milliliters 1NH2SO4, acid used equals 100 to 80 equals 20 milliliters 1NH2SO4%. N equals 1.4x. Normality of the acid x volume of the acid used. Mass of the substance taken equals 1.4x. 1x 20 equals 23.026 1.216. Material downloaded from SUPERCOP 16/16.